you ever thinking why did the sound of an ambulance with an open siren likely to be louder as it comes towards you? And how about it move away from you? This is called Doppler effect. An approaching source moves closer during period of the sound wave, so the effective wavelength is shortened, giving a higher pitch since the velocity of the wave is unchanged. Similarly, the pitch of a receding sound source will be lowered.
Now we consider the case when the source is moving to the right with velocity v. The arrow shows the wave crest emitted by the source when it is at point 1. What we need to find is the new wavelength, denoted by initial wavelength. From the drawing, we can see that the new wavelength, lambda prime, is equal to the initial wavelength minus by velocity times the period of the source. This is the equation that we get from the sound, Vs. We substitute T into the previous equation. We get the formula in terms of frequency.
For application of Doppler effect, let's say you are standing in the middle of the road. That's you, and a car drives past you very fast. Its horn is on because you are standing in the middle of the road. So it starts at a high pitch and move to a lower pitch, even though from the driver perspective, the horn is playing at the same pitch at the entire time. So what's going on? As the vehicle coming towards you, the sound wave that is emitting bunch up, and so are delivered at you at a higher frequency, which you interpret as the higher pitch because the frequency of the sound wave is pitch. And then when the vehicle passes you and it's moving away from you, the sound waves spread out, and so you hear them at a lower frequency.
Okay, let's do some example question. An ambulance transmits a sound with a frequency for 3 meters per second. We have the source and we have the observer. The question is asked the source is moving from this question. Frequency 800 Hz. Frequency of the source is the 800. We can use in this question. The important formula is the frequency observer equal to the over velocity plus minus velocity source. Then we just sub the value. Frequency source is 800, velocity 343. The sign at the numerator doesn't matter, plus or minus, because the velocity of the observer is 0. The sign at the denominator, we use the positive, because we must get the frequency observer is less than frequency source. Since the source is moving away, we want the value of whole fraction is decreased. So to get the frequency observed decrease, we must to increase the denominator. So we use the sign positive. The velocity of the source is 73. So we get the answer 735.7